Hello everyone, welcome back to my channel. Today's video will be on the function y equals to x power 1 by 3. I will first discuss how to draw this function and lastly I will discuss the properties of this function. So let's get started. So here we have this function which is y equals to x power 1 by 3. Now we have already plotted the function y equals to x square. This function we have x cube. So this function we have already plotted. Now there is a concept of inverse function which we need to plot this function x power 1 by 3. So suppose if we take a function fx like x cube and another function gx like x power 1 by 3. So what happens if we put them one after another, then the function reduces to the original function x. So let me write it down. Here we have suppose the function as fx equals to x cube and another function gx as x power 1 by 3. If we take the composition of these two functions, we will get what? We will get x power 1 by 3 whole cube. It will reduce to x. So, if composition G becomes the identity function, this kind of functions is called the inverse of a function. So, what happens in case of inverse? Let me write it down. So, suppose we have a function from a to b f such that y equals to fx. Then the inverse of this function is this function g. Then what happens? G of y is x. Okay. So if we put them one after another, which is called the composition of function, the original x returns. So we start with x and that after operating f, x becomes fx equals to y, and if we operate g on this y, we will get the x pair. So suppose we have this y equals to fx and the inverse mapping becomes x equals to f inverse y. So what happens here is that x and y gets interchanged. So that becomes a key part in plotting the inverse of a function, that y equals to x curve. Okay. So here if f is an inverse of g or g is an inverse of a, what happens in case of plotting that curve is that graph of g becomes the mirror image of f of graph of f with respect to not g, it should be like y equals to x. Y equals to x. So the graph, the inverse function graph becomes the mirror image of the original function with respect to the y equals to x curve. So as I have already mentioned that this function here, this function x cube is the inverse of x power 1 by 3. So we have already plotted x cube. So from there, if we take the mirror image of that x cube graph, we will get the graph of x power 1 by 3. So let me show you here. So here, this graph, this one, this blue colored graph is the y equals to x cube. So the blue colored graph is y equals to x cube. Here we have taken this y equals to x. So if we try to take the mirror image with respect to this y equals to x, we will get this part's mirror image as this. Again, this part will have the mirror image like this. Again, this part will have the mirror image like this, and this part will have the mirror image like this. So by using the y equals to x cube function, we have plotted here the function y equals to x power 1 by 3. Okay, so if we draw it in single plot, so we will get this curve as the y equals to x power 1 by 3 graph. So we have plotted the graph. This is the first part of this discussion. Now let's move on to the second part of this discussion, which is the properties of the curve y equals to x power 1 by 3. So firstly, we start with the domain and range of the function y equals to x power 1 by 3. So from here, it is obvious that this, the input, the domain spans across this whole x-axis. So the domain must be whole real number, and also the range also expands across the whole y-axis. So the range must also be R. So here we have domain R as well as the range R. Next is as x greater than 0, y is greater than 0, and as x less than 0, y is less than 0. So it is obvious that here what happens? Here if we try to see it, x greater than 0 means this part, and y greater than 0 means positive y-axis, which gives us the first quadrant, and this is the first quadrant, and x less than 0 means this side, and y less than 0 means this side. So this part, the second part, accounts to this third quadrant. So we have already plotted this curve, and we have seen that this curve obviously lies in the first and the third quadrant. Now let us move to the third property, which is that it is an algebraic function. Moreover, it is an irrational function. So we have already seen it for the case of x power half. Next, it is an increasing function. So from the graph, it is obvious that as x increases, y is also increasing like this. Okay, so now we need to prove this. So for mathematical proving, we can see here that suppose we take the function as fx x power 1 by 3, and if we do the derivative will give 1 by 3 x power 1 by 3 minus 1. So it will give x power minus 2 by 3. So it will give us 1 by 3 into x power 2 by 3. So it is actually 1 by 3 into 1 by x power 1 by 3 whole square. So whether x is positive or negative, 1 by 3 might give the positive and negative terms, but as there is a square, it must always be positive. So f dash x here is always strictly greater than 0. So that means f is increasing function. Next, this function is convex is minus infinity to 0 and concave in the interval 0 to infinity. So we can again prove it by the derivative. So fx is x power 1 by 3. We have already found the f dash x, which is 1 by 3 x power minus 2 by 3. Now if we try to put the second derivative, we will get that 1 by 3 into minus 2 by 3 x power minus 2 by 3 minus 1. So it will give minus 2 by 9 x power minus 5 by 3. So it will give minus 2 by 9 x power 5 by 3. So as x is greater than 0, it means x power 5 by 3 is greater than 0, okay, but there is a minus sign. So due to that minus sign, if double dash becomes negative, so in this case for positive x, it becomes concave, and when x is less than 0, x power 5 by 3 is less than 0, and for this again as there is a minus, so if if double dash x becomes greater than 0, so that means convex. So in the negative side, the function is convex, and in the positive side, the function is convex. Okay. So let us see it in the figure. So obviously in the negative side, the graph is convex, and in the positive side, the graph is concave. Okay. So I think, yeah. Next is it has no maxima and minima. So obviously as f is always increasing, okay, so as f is always increasing, so it will have maxima and minima at the end point, that means at plus infinity or minus infinity. But we can see here that as limit x tends to infinity, x power 1 by 3 tends to infinity. Okay. And same for the minus infinity, as limit x tends to minus infinity, x power 1 by 3 tends to minus infinity. So it has neither maxima nor minima. Okay. Now it is an odd function. So in case of odd function, what happens is that the function must be symmetrical about the opposite quadrant. So we have already seen it, that the function lies in the first and the third quadrant. So for proving that, we can see here that if fx equals to x power 1 by 3, then f of minus x becomes minus of x power 1 by 3, and we can write it like this, minus 1 into x power 1 by 3. So it gives minus 1 power 1 by 3 into x power 1 by 3. So it gives minus x power 1 by 3, and that means it is minus fx. So fx is an odd function. Okay. Next, it is continuous in R, and okay, so it is continuous in R. Let us first check that from the figure. So from the figure, it is apparent that we can draw the function without putting out our pen or pencil. So we can draw it continuously. Okay, so we need to prove it. So for proving it, we start with the limit, and obviously if a is any real number and we try to take limit x tends to a fx, it will give limit x tends to a x power 1 by 3. So there is no problem, we can directly put the value, it will give a power 1 by 3, and it is equal to f of a. So as these two are equal, so it is continuous in R. For differentiability, what happens is that we try to take the limit x tends to a fx minus fa divided by x minus a. Now our fx is x power 1 by 3, and here we have a, which is a power 1 by 3, and in the denominator we have x minus a. So we can write it as this minus this. So we can apply the a cube minus b cube formula, and we will get limit x tends to a x power 1 by 3 minus a power 1 by 3 divided by x power 1 by 3 minus a power 1 by 3 and square terms sum plus a power 2 by 3, and there is a plus term which is x power 1 by 3 a power 1 by 3. Now we can cancel these two out as x is not equals to a, and we can put the a in the denominator. So it will give 1 by, all of these terms will become identical. So there will be 3 a power 2 by 3 terms, and it will give 3 a power 2 by 3. Now this occurs if a not equals to 0. As at a equals to 0, there is a problem. What happens is that at a equals to 0, the function becomes concave to convex. So at that point, the function, so let me show it here. Okay, so this point here is a point of inflection. Okay, so we can see here that in the graph that this function becomes convex to concave at the point x equals to 0, and when we have tried to find out the derivative here, so let me show you. So the function, okay, so let me write it down. Fx, the derivative is 1 by x power 2 by 3, and there is a 3 here. So it tends to infinity as x tends to 0. Okay, so at the point x equals to 0, it has the infinite slope. Infinite slope means it has a vertical tangent there. So if we try to draw the tangent at the point x equals to 0, it will have a vertical tangent there. So that function is not differentiable at that point. In the next video, I'll be discussing the general forms of x power 1 by 2 and x power 1 by 3 functions. So those forms will be x power 1 by 2n and x power 1 by 2n minus 1. So those two functions will be covered in the next two videos. Thank you for watching this video. Please like and comment to this video and subscribe to my YouTube channel. Thank you.